So a distance is a measurable unit given 2 points. So you're always going to have some from 2 points. It's always going to be a length. And a distance is never going to be negative. You're never going to say, I'm going to go backwards -3 miles. You're just going to say I'm going backwards 3 miles, right? So it's never a negative number. So here on a number line, you're going to use the formula, and I used AB to represent these letters here. So the distance of AB is going to be equal to the absolute value of x1 minus x2. X1 represents this point here, and x2 represents this point here. It's not an exponent, it just represents the different point. Then we have here the distance formula. So the distance formula here is D. D is for distance, right? So no tricks there. The square root of x minus 2, or I'm sorry, x2 minus x1 squared plus y2 minus y1. The actual order of x2 and x1, it doesn't matter. So you could potentially do x1 minus x2. You just have to do, and you can also do the y1 minus, y1 minus y2. It does not matter that order, okay? Okay, then we have the midpoint formula. So midpoint is going from 2 points and you're finding the direct center of it. So a point is midpoint of a segment if, and it has to be a segment, it can't be a line because you're going from 2 points. So here you're going from 2 points. So this entire distance here. So it's not just going to be the entire line, it's the specific part of that line. If and only if, IFF means if and only if, it divides a segment into 2 segments of equal length. Notice the tick marks here. The tick marks, again, are showing that they are congruent. So the pictures are the same of them. The size, we don't know the size, but in this case, we just know that the picture. So then the midpoint on a number line. So some of you are looking at this formula here, and I have x1 plus x2 divided by 2. It's essentially just you're finding the average. Remember finding the average. So like, same thing here. You're going to have one talking about the x's and one talking about the y coordinate. My hint to you guys, or my tip, is to always label it. So let's say that this is going to be your x1, y1, and over here this is going to be your x2, y2 point. It does not matter which one you pick as your 1 or your 2, as long as you represent one of them as either or. And then over here, you'll notice how I have xm and then comma a ym. The m just means midpoint, nothing fancy. Okay, then over here we have a segment bisector. So a segment bisector, a segment is a segment bisector if and only if it passes through the midpoint of a segment. So over here I have a picture drawn. So this line here, that's the segment, right? It has the 2 endpoints. That is the segment. And I'm going to name that as, let's put an A and a B for our segment. And let's label this as line L. So over here, this is our point. I'm going to put an M just to represent the midpoint, but I'm always going to name the points. In this case, I just chose M. This segment here would be congruent, so a segment bisector. So a segment is a segment bisector if it passes through the midpoint of a segment. Now we're going to go ahead and do a couple examples. So here, on a number line, A has the coordinate -1 and B has the coordinate of 8. I am a big believer in drawing a picture helps everything, and it helps make things easier. So we have point A and we have point B on this segment. Alrighty, and then we know that A has the coordinate of -4 and B has the coordinate of 8. So we're going to talk about this distance between here. How do we figure that out? Now, I know some of you can look at it and just know what the answer is, but if we are going to use the formula that I gave you on the previous page, AB equals the absolute value of x1 plus the absolute value of x2. I lied, it's the minus, so it's minus x2. I apologize there. So then here you just plug it in. So I'm going to go ahead and have AB equals the absolute value of -4 minus 8. I'm going to subtract those, subtract them, and then we'll get here a -12. But now because we have the absolute value, it gives us a +12, so that distance is 12. Now remember, the way that this AB is written is talking about the length, not the picture. So if I were to talk about the segment of it, I would put the bar on top of because it's the length. We're just going to have that there. Next, we're going to have the coordinate of the midpoint. So now I want to find the midpoint. What is the midpoint of AB? So we're going to go ahead here. The midpoint equals, the formula is x1 plus x2 divided by 2. And now because this is not a coordinate, we're going to be using this formula here because we're just looking from two different numbers. So we're going to have negative 4 plus 8 divided by 2 equals 4 over 2. And always reduce your fractions. And then you'll have the coordinate for your midpoint is 2. Alrighty, you can also go in the other direction. So let's say you went here of 8 plus negative 4 divided by 2 instead. That's totally fine. You're still going to get the same answer of 2. Alrighty, the next example, and reminder as I'm going through, if you need to pause me or go back, go ahead. You can pause and rewind, whatever you need to do. So the next question is, on a number line, R has the coordinate negative 5 and P has the coordinate of 6. So I'm going to go ahead and draw ourselves a picture. So we have an R and a P. R has the coordinate of negative 5, P has the coordinate of 6. It says find the coordinate of T so that P is the midpoint of RT. Okay, well, I'm going to say that again. So find the coordinate of T so that P is the midpoint. So that means we're saying that this P here is going to be the midpoint. So I need to then figure out, and I'm going to extend this line here, I need to figure out what T is. Okay, so I know that P is the midpoint. So over here we have our formula, MP equals x1 plus x2 divided by 2. So over here, I'm going to plug everything in that I know. All right, so we know our midpoint is 6, so it's going to be 6 equals. We know that one of our points is going to be negative 5. So equals negative 5. And then we don't know our last point, so I'm going to put a plus t. And then divided by 2. From here, we are just going to solve, so multiply both sides by 2. So then we'll get 12 equals negative 5 plus t. When I add 5 over to the other side, we will get t to equal 17. So we know that our point T has the coordinate of 17. Alrighty. Now, again, I know some of these problems you can do it without using the formula, and I understand that, but I'm just going through the motions of that formula. The last problem here has a lot of different parts, so remember at any time, please go ahead and pause. So whenever I'm doing these problems, I always like to put the formula on the page in front of it, or on the actual page for that question, because I know I'm going to use the formula, and then when I have it in front of me, it reminds me, and I know exactly where everything is going to go, so I don't have to guess here. So it says, use the diagram to find. So here it says AB equals. That is talking about the distance. So we have here AB. Well, I need to find the distance of AB, but I'm only given 2 coordinates. So I'm going to go ahead and label this as x1, y1, and this as x2, y2. So then from here, I'm going to go ahead and use those points in the distance formula. So we will have D equals the square root. Okay, the square root, and I'm going to have our x's first. So our x2 is 7, so we're going to have 7 minus negative 3 to the power of 2 plus parentheses 2 minus 5 squared. And then we have here equals. And then underneath, we're going to have a positive 10 squared plus, that's going to be a negative 3 squared. Then we will have a 100 plus 9, and that will give us the square root of 109. And if you're able to reduce your radicals, you reduce your radicals. But in this case, we are not able to reduce this radical. It will stay as it is. I do not want anything in a decimal. So unless I say write a decimal, that's when you write a decimal. If it doesn't say it, you leave it. All right, then the next part here is the coordinate M. So we need to figure out the coordinate M. So that is this step here. The first step was finding there. So coordinate M, that is going to be, it looks like the midpoint. I know that it's the midpoint because I have these two tick marks here and it's telling me that AM and MB are congruent to each other. So I'm going to use that midpoint formula that I also have written down here. I'm going to use those points. I'm going to use the x2, y2 and the x1, y1 in that same exact way that I used in the first problem. So over here, I'm going to plug it all in. So we're going to have x, y, right, our midpoint, I'm going to put a little m there, equals, parentheses, our x1 is going to be, so x1 is -3, and then plus 7 divided by 2, and then 5 plus 2 divided by 2. When we go ahead and do that, we will get some lovely fractions. So we'll have 4 over 2, and then 7 over 2. You will always reduce, so our final answer is 2, 7 over 2. Leave it as a fraction. I do not want a decimal. It will drive me crazy if everything is written as decimal. So that is the midpoint. Okay, last example. This one is a little tricky. So over here, finding the coordinate of C. So this entire line here is what we're looking at, and we want to find the coordinate for C. We know one endpoint and we know the midpoint. So over here, since we know what the midpoint is, I'm going to go ahead and write 2, -1. That is the midpoint. We do know our x2 and y2, so I'm going to plug those into the respective spots. Well, so we're going to have this here divided by 2, and then this is a plus 7, y1 plus 2 divided by 2. Notice I did not add in the other point. I'm representing that one as our C, so is our x1 and then y1. I don't know those points. Now, over here, I do know that the whole point for x is 2, but I know this is what will get me 2. So I'm going to go ahead and write 2 equals x sub 1 plus 7 divided by 2. That is going to get me the point for x. And then over here, I'm going to have -1 equals y sub 1 plus 2 divided by 2. Once we go ahead and do the math, right, I'm going to multiply by 2, we'll get a 4 equals x sub 1 plus 7, and then we will get x sub 1 equals -3. You'll go ahead and follow that same procedure for the next problem, and we will get y sub 1 equals -4. Then that means we're going to have this x1 and y1. We can say that C, our point C, is going to be 3, -4. Alrighty, so that is it for midpoint and distance. If you have any questions, just let me know.